Hi, in this video I'm going to show how to use an enhanced version of the spreadsheet that was included in this article on seekingalpha.com. Here are the links to the article, Yale Professor Schiller's original spreadsheet that the author modified, and my modified version of that. These links are in the info section below. The first two are Google Docs, but my version is Excel only. And I do recommend that you read the article before watching the rest of this video. So please do not construe this video as financial advice. The disclaimer from the article itself applies to this video, and that is that you should not rely on it for any reason other than entertainment. You should also note the limitations and assumptions of the model. It assumes that the entire portfolio is in the S&P in an S&P index fund such as the SPY ETF. Dividends are used first for withdrawals, and then shares are sold if that's not enough. And the whole point of the article is to show the effects of a variable withdrawal strategy where a fixed amount is withdrawn every month, rain or shine, and when the market is up only, a discretionary amount is also withdrawn. And there's no accounting for any other sources of income such as Social Security, pensions, and so forth. So taxes and fees are not accounted for, so those would just be expenses that must be covered by withdrawals. And so I've listed here the enhancements that I made to the spreadsheet, and we'll see those shortly. The reason that I didn't put the spreadsheet on Google Docs is that some of the changes I made don't work properly, and I didn't have the time to figure out if it's possible to make them work. So note that I am running an older version of Excel on a Mac, and it should work fine as long as you aren't running an even older version of Excel. Some things might look a little different for you if you're running on Windows or running a newer version. So a very important thing to realize about this spreadsheet is that all the dollar amounts are adjusted for inflation, and that's what really makes this useful. And then here once more is the link to the spreadsheet. Okay, so here we are in the actual spreadsheet itself. First thing to point out is this first column here is the date, so year and month. Every row in the spreadsheet is a month. These yellow boxes up here at the top are where you can make some changes to change the behavior of the model. This one right here is the starting date, so I'm actually going to jump down to there. In the spreadsheet, you can see that lines start turning green there. So this here, this is the starting amount. Again, this is in today's dollars, so I'll adjust it for inflation, and you can see that's the initial amount here, in this case in January of 1925. This amount here is the fixed rain or shine monthly spending amount, and then here and here are the variable spending amounts that you would only spend when the market's up, and they're sort of, this is the way the author set this up. So it can either be a percentage of the gains in the previous month or a fixed amount only when you have a gain. So next thing to show is, let's go to the bottom of this column, and you can see this is the sort of ending amount, and this is actually in 2017, so basically now. And we can see if we change this to 0, it would be a huge number. Let's change it to 10,000, and then we actually went bust. So what I think is most useful actually is to try to find the value where you end up with the same amount that you started with. And a nice feature in Excel allows you to do just that. So this may look different on your version of Excel, but I think it's generally going to always be on the data tab, and then this what if, and then it's goal seek. And so I'm going to say 1.5 million by changing this cell. And it's just going to go and do this guessing and checking until it finds a value that solves that. So this is saying that if you spend a fixed amount of $96.58 every month, you'd end up 93 years later, or whatever that is, with the same amount that you started. Okay, so now we can come down and look at some of these other tabs. I'll look at this 12-month spend tab, which is a graph of the sort of running 12-month spending rate, which in this case, since we're spending a constant amount, is just a straight line, and it's a little under 116,000. Then there's this graph, this total spend versus portfolio. So this red graph is the portfolio value. You can see it starts and ends the same amount. This axis is the portfolio value, so you can see that's 1.5 million. The blue line is a cumulative spending amount, and you can see after 90 odd years we've spent about $10.7 million total, and this axis is what is the total spending amount. So there's also this tab, this SP500 tab, which the only thing that changes on this tab is where the red line is, which is what date that you've chosen. This shows the stock market value in today's dollars. This is a logarithmic scale on the value side. But what you can kind of see from this is that this January 1925 date that was chosen in the article as sort of the example is not really a very conservative guess on where you might want to start, because even though it is before the Depression, the stock market crash, Depression, World War II, and so forth, it's only maybe a third of the way up through this boom in the Roaring '20s. So you may not want to actually be the ultimate pessimist and choose September of 1929 as your starting point, but you might want to choose somewhere that looks a little bit more like where we are now. You can imagine this coming down if you want to plan for at least a somewhat pessimistic scenario. So one way to tell that this is not very pessimistic is looking at this tab, which is the spend percentage. And you can see this started out at about almost 7%. So the 4% rule says that you should start out at 4%, and then you're pretty safe. So I'm going to go back to the data tab. Okay, so let's go and change this date to, we'll do 1965. And you can see that was more pessimistic. We ran out of money if we wanted to try to spend at the same rate. So let's target, I'm going to show you a little trick, which is instead of targeting this, let's target this. What if goal seek, say 100% by changing the cell. Okay, so before we were able to spend, if we started in 1925, we were able to spend almost $10,000. Now we're only a little over 4,000. So you can see that's much that is a big difference. Here's where we are time-wise. Now we're spending about $52,000 a year. Still go up and down, still end where we started, but over the course of that number of years, well, this is not very, can't really compare this with the other one, but this was definitely a more conservative time, and you can see that we're just barely making it, and yet we started out at 3.3% of our portfolio value. So this is where the 4% rule comes from, that it's not a guarantee, because if you sort of pick a bad time, you might fail even with 4%. So that's probably enough to get you going. I'm going to do a part 2 of this where I show the actual feature of showing the optional spending. I'm also going to show how you can use the two scenarios that I have in here and compare the two.